For this LanceDB Quick Bite, we're going to walk through using the included Python example that illustrates how to improve RAG with re-ranking. We start in LanceDB Cloud inside our DevRel SAMP project. A link to our Getting Started video is in the description if you are unfamiliar with the system. Now let's click on the Colab link here for Improve RAG with Re-ranking. If you want just the code, click on the Python link and you'll be taken to the GitHub page. The first thing we want to do is spin up the runtime. Check the runtime type to ensure you have the GPU option enabled. Otherwise, things are going to run pretty slowly. So we check here on Change Runtime Type. We have T4 GPU, and we're fine. That was already displayed here, but we wanted to double check. As you can see, this Colab is well commented. But to summarize, the problem we're addressing is the limitations in the RAG pipeline due to the restricted LLM context window and potential inaccuracy in the embeddings and search algorithms, resulting in unrelated results when fetching top N related chunks for user queries from large documents. The proposed solution involves re-ranking chunks retrieved from the corpus to improve precision. This method leverages recall to obtain a higher number of related chunks N, then uses a powerful model for re-ranking to enhance precision, ultimately selecting a smaller subset, K, of top queries to pass on as context. Using a larger model initially isn't feasible due to the vast domain size, as even with a big model, irrelevant results persist, while employing a smaller model with an efficient search algorithm balances broader coverage with improved relevancy through precision re-ranking. There are two things that we need from LanceDB, and the project here makes it simple to plug them in. The first is the project slug. If we look back here, we see the slug at the top. This is also displayed with some sample code with the mouse hover operation on the exclamation point here. I've already created an API key that I'll be using, but you may want to create a new one. So we come back here and we paste in our project slug. Next, we want to pop in our API key and we put that there. You can see they've been brought over into the code. We'll execute these two cells. Click through that. These just take a second. Now there's an alternative way to walk through this by setting it as an environment variable, but that's not what we're going to do here. Now we move on to installing all of our dependencies. Well, at least the dependencies for this part. If we get any errors or warnings about versions, this is not a problem if everything runs correctly at the end. All right, that's done. For anything that's going to take more than a second, we're going to edit that timeout, so you might see things pop around a little bit. Next, we want to import these libraries. So we're going to grab our embedding model down here and our re-ranking model down here. Everything's loaded up. Now we want to load the chunks of data from the Bell R dataset. This is hyperlinked if you want to go to that. While that's loading up, I want to note back in Lance, if we look at the tables, the table that we're going to be working with is doc_embed. Now, I've already created it because I've worked with it before, but we're going to see a create or open option a little further down. So we're going to get the embedding and we're going to create the database or open it, which is what I was just talking about. Here you'll see this try except clause. This keeps it from failing if you've been running it a number of times. This takes a little while to run the first time. So let's just point out a couple of things here. You can see the time everything took to run over here, and that was 6 minutes. But let's point out we bring our project slug variable from the top. Here's the table we talked about, doc embed, and our whole LanceDB connection string with our API and our URI. So our table is built. Let's search some random text. That ran quickly. The query was the ontology extraction and maintenance framework text to onto. So we have some results here. Now we're going to re-rank those results using the re-ranker from BGE re-ranker. And pass all the results to a stronger model to give them the similarity ranking. So that comes back pretty much instantly. And you can pause and take a look at what's happening there. But that's the end of our Colab. There's not a lot of steps involved. There are some libraries and functions that you need to make use of. But this is pretty clear in how the process flows and how you can do a re-ranking with it. Visit our website to find out more.